Hello everyone. In this video I'll talk about Maxwell's second equation, also known as Gauss's law for magnetism. In my previous video I talked about Gauss's law for electric field, which was Maxwell's first equation. So in this video I'll talk about how magnetic field behaves in the presence of magnetic poles. So if you haven't watched my first video, I'll highly recommend you to do that, because these two videos are highly related to each other, connected to each other. Okay, let's go ahead and get started. Okay, now again we have this balloon analogy. I have a balloon filled with now a magnetic charge, not the electric charge. So when we try to zoom in here again, so we should be able to see again this kind of patch. So all I'm doing is I'm zooming in here. So now it's curved because it's a balloon as a result of pushing from inside the wall, so it makes this kind of concave shape. So now we have here magnetic charge there instead of electric. So I'm just gonna put the magnetic bar. We all know this, the magnetic bar. It has two poles. It has a north pole and it has a south pole. So now how does it behave and how it can really affect the total magnetic field here? So unlike electric field, where the positive charge actually try to push the electric field outside of the balloon or surface, and a negative will push inside. So magnetic field behaves a little bit differently here. So how does it behave? So here what happens is, when from north side, the electromagnetic field will leave and then turn back and gets into the south side. So basically it's the field lines that go out, one side will curve back into the other, as shown here in this figure. So we have one field, and then the second field also will go and then come back and then cancels out. More field come, more field, the number of fields that coming out will come back and in, and then they both cancel out. I hope I was able to explain that. So basically there is no single magnetic monopole. So what does it mean? So when we have a magnet bar, so we know we have a north and south pole. So the big question is, so what happens when we split the magnet? Let's see, we have split the magnet right from the middle. So what happens? Can we just split it and then put that back here in our balloon and then have a magnetic monopole? So let's find out. So what happens is, we have now two pieces of magnets, because we know we chopped it in, and I apologize for this drawing. So I'm just trying my best to draw as accurate as possible. So now we have two magnetic bar. So now can we split that north and south pole? Actually no, we can't. So what happens is, again, it's going to generate north and then south pole. So what happens if we split these two magnets into two? So we have now two teeny tiny magnetic pieces, the magnetic bars. So what happens is, they are all also split into north and south. So it doesn't matter how much you chop, how many times you chop the magnetic bar, so that always generates the north and south. So this is kind of the beauty of the nature, the beauty of the magnet. So in that case, when you see here, there is no any magnetic monopole, there is no a single magnetic charge, just like you saw it in electric charge. So that's why whatever field which is coming out will curve back in, and then it will just cancels out. So how does it work in terms of equation? In terms of equation, just gonna write it again, the same integral, and then magnetic field times, again we have this dA, and I apologize, in my previous video I said delta A, and it's not delta, it's dA. So again, it's a vector. So now here, now in this part, and what I just said, there is no any magnetic monopole, which is Q is always 0. Then we have epsilon. So basically, we can also write it as 0. So since the Q is 0, it all cancels, it all becomes 0. So basically, so there is no any magnetic monopole, or they can also say that the resulting being 0 tells us there is no net source or sink of magnetic field inside the surface, so no single magnetic pole or charge. So this is how the magnetic field works. So unlike electric charge, you cannot collect just the north pole or south pole in one place. Magnets always have poles. So if you cut a magnet in half, you simply get two smaller magnetic pieces. So this is the essence of Gauss's law for magnetism. It says that if you take any closed surface like a balloon and look at how magnetic field line passes through it, the net flow magnetic field coming out of the surface is always 0.